So when you deal with the databases, you are supposed to deal with the entities and the relationship in between them, and obviously the attributes will be associated with the entity. Yeah.
Okay, yeah.
Then any entity will have a kind of relationship like one-to-one, one-to-many, many-to-one, and many-to-many. Yeah. And those, one-to-one, one-to-many, many-to-one were clear. And as I told you that many-to-many is, literally possible, but physically it is created with the help of a third entity. Like one entity is associated with another entity for many times, and that entity is associated with one entity from many to one time. So there is an example, in next slide, so we will discuss. Yeah.
Yeah.
So relational model, we discussed that it's discussed in the tuple attributes column, and the relation is called the table. And furthermore, we talk about the schema. Basically, the database schema is the skeleton structure that represents the logical view of the entire database. Yeah. So obviously, as I discussed yesterday, that the data is stored in the digital form like in zeros and ones. Yeah. But when you look at the database structure, then you talk about the database schema. Yeah. So
Okay, yeah.
it defines how the data is organized and how relations among them are associated. It formulates all the constraints that are to be applied on the data. A database schema defines the entities and relationship among them. So everything you try to talk about the entities, their relationships, it comes under the schema. So let us have a look on the database schema. Like physical schema describes, the way how data is stored in actually. Yeah, like in the files and their directory structure. And the logical schema, would show you its representation, that how, for example, the it looks like it looks like a student table, it looks like course table. Yeah. So physically, obviously, the way we store the data, it won't be looking like a table inside the hard drive, is it?
Yeah, okay.
Yeah, makes sense.
Yeah, makes sense.
So physically, the things are, blind, and when you try to make an image, then that would become a kind of logical schema. And then the furthermore, the physically and internal are sometimes called the physical, schema. And then on the top of it, there is a logical schema, and it is connected with external level, which is basically the user level.
Okay.
Yeah. So physical schema, logical schema, and then connected with the external level, which is the user level indeed.
Yeah, okay.
Yeah. So whenever you are talking about, the database levels and going to go through, so somebody, is giving you the triggers about the physical schema, then you are going inside the computer. And when they talk about the logical schema, then you come up into the entity relationship diagrams. Yeah. And when it comes to the user view, then you exactly look at the output of the database, maybe in the table, maybe in the form. Yeah. Maybe on the web page, whatsoever, you are interested. Yeah.
Yep, understood.
Yeah. So these are the definitions about these external, logical, and internal and physical, data. Yeah. I think there is no need to explain, word by word. You understand well that how they needs to be.
Yeah, that's fine. Yeah.
Now, big data. Like, this is the just random topic, or I would say random topic, or a sequential, introduction to the databases. So the big data is basically really big data. Means really a big data is a collection of large data sets that cannot be processed using traditional computing techniques. Big data is not merely data, rather than becomes a complete subject, which involves various tools, techniques, and frameworks. For example, black box data, yeah, social media data, stock exchange data, search engine data. So if you imagine that that black box data, what it is, the black box data and used for. Have you heard about it?
Yeah. If there's a problem with something on an airplane, a helicopter, etc., it records all the events, and then hopefully they can find out what's happened.
Yeah, what I would say, it reports, in other words, it stores all activities, and whenever you try to access the black box, then you got to know that what had happened. Yeah. So
Yeah.
sometime what happens, when the airlines, get disconnected with the control room, yeah, and how long the airline was, in the sky, for example, what noises were made, what approaches were made. So those, that particular data is stored using the black box, and obviously that's not our topic, but that kind of, extensive data is comes under the big data. Social media data is not the, for example, if we take the example of the Facebook, and it is not stored on one computer and one database. Yeah, it's under the big data, which involves lots of tools, techniques, and frameworks. Yeah, we can't, obviously their structure would be, maybe public, yeah, but entirely different thing than the conventional databases. Make sense?
Yeah. Yeah. It all makes
So
sense.
that's a
Yeah.
field basically. People, explicitly take this field to study these, things, and that's an interesting field as well. Yeah.
Yeah. Okay.
So big data includes the huge volume, high velocity, extensible variety of data, and the data, it will be in the form of types, three types: structured data, yeah, and semi-structured data, and unstructured data, Word, PDF, text, media, logs, yeah. So the big data can deal with normal relational databases as well as XML, and it can also deal with the Word, PDF, text, and media logs as well. Now, big data management is the organization, administration, and governance of large volumes of both structured and unstructured data. Yeah. So it's not only the case that everything is under, control and under a schema, but if it is unorganized, for example, any data which is in the Word file, then obviously it is unstructured. Yeah. Then big data also manages it. Yeah. So it ensures the high level of data quality, accessibility for business intelligence, and big data analytic applications. So corporations, government agencies, and other organizations employ big data management strategies to help them uh, uh, contained with a fast growing pool of data. So simply, big data, when it comes to the usage of the data at the large scale, the big data is used, right? So however, we are focusing on the relational database only at the moment, so let us focus on this. Let us, move further, and don't need to go into the details. Yeah.
Yep. That's fine. Yeah.
Yeah, just share.
Hello. Hello.
Hello.
Hello.
Sorry, don't know what happened. Join me was disconnected.
Okay.
So I will have a look at what was the reason. So big data applications, that's used in the banking and securities, communication, media, healthcare providers, education as well, on the large scale projects, manufacturing and natural resources, and yeah. So big data, from the introductory point of view, there's sufficient here that it deals with the very big large applications which are beyond the the uh, capabilities of the normal data. So big data is used. The next topic is the transaction processing. In computer science, transaction processing is information processing that is divided into individual operations called transactions. Each transaction must succeed or fail as a complete unit. It can never be only be partially complete. So there's a concept that certain when you use the databases, then there is a category of transaction processing you deal with them. Yeah, and in the transactions either they succeed or fail, but do not remain in the middle. For example, if you transferred money from the bank account and it will only be deducted from your account uh, only when if somebody received it and got a confirmation, and then your money will be taken from your account. Make sense?
Yeah.
I wish that if the somebody would wish that if you try to send the money and it reached to their account but didn't detect it, our account. For example, it used to happen sometime ever. But I think that in the older, when the e-com was not that much sufficient, yeah, then people used to say, oh, we have received money, but your account is not charged yet due to some problem. Did you ever get this chance to know about it?
No, that's never happened to me before. No.
Yeah, but as I remember that ages ago, there used to be certain things like, that we have received amount, but due to some reason, even, what happens, they take the payment, yeah, and the card is charged, later on, but it takes, some seconds, few seconds, something like that, yeah, and that's basically the transaction processing. However, obviously they make sure that there are sufficient funds, yeah, and but transaction processing systems make sure that they fail or succeed, but that's not in the middle. Yeah.
Okay. Yeah.
Okay. So some theoretical, on the transaction processing, and like they have states, transaction states like active, partially committed, failed, aborted. So any transaction which goes through, it goes through the certain states. So when it comes into the action, it becomes active, then partially committed, then failed or aborted. The reason is, for example, you wanted to transfer the money, it came into the active, condition. Then when money reached to their account, it was partially committed. And when you got to know that money has reached, for example, then before committing, your money was taken as well, yeah, and it's done or committed then. Make sense?
Yeah. Yeah.
Yeah. So all goes through the kind of synchronous and into the states, yeah, then and then certain transactions, get successful or maybe aborted, whatsoever. Yeah.
Okay, yeah.
Yeah, there's another, area which is OLTP, Online Transaction Processing, is a class of software programs capable of supporting transaction-oriented applications on the internet. So this is basically the kind of protocol, yeah, used in the such kind of applications. Yeah. So certain, OLAP, multimedia type of, models. So I'm giving them a name of protocol. Yeah, some of the applications, they work according to a kind of protocol. It's talking of, it's about OLAP kind of thing. You understand what the protocol is?
Yeah, it's like a set of rules, isn't it?
Yeah, set of rules, like, when we say that we use the internet over the TCP/IP protocol.
Yeah, that's it. Yeah, I get that. Yeah, yeah.
And for example, if you connect the database with the application, you talk about the ODBC.
Yeah.
Yeah, object database connectivity, and you connect with the database with the JDBC, Java database connectivity. So these are the protocols basically. Yeah. So
Yeah.
OLAP is also the kind of server type protocol which is supported for which is used for databases. Yeah.
Yeah.
Then data integrity is the quality management. Data quality management is an administration type that incorporates the role establishment, role deployment, policies, responsibilities, and processes with regard to the acquisition, maintenance, disposition, and distribution of data. In other words, role of assuring the quality of data being represented or produced. So when you talk about the quality of data, then you talk about the data integrity into the database. Yeah. So how data
Okay.
integrity, applies, you really, implement certain features. Yeah. So database quality control depends on the technical quality functions, yeah, which consist of activities of quality requirement and specification, quality planning. Primary goals of this function is to define the database quality and quality measurement function. For example, quality element in database, one can develop a goal regarding the percentage of the non-conformities allowed. Basically, this is a kind of, again, a random topic. Yeah. I'm sorry, that it's not my wish to take the random topics. Yeah. But, the course providers, they have given such kind of, the random topics like, database management system, architectures, big data, transaction processing, data integrity, and, these things. Yeah. So that's why I'm just giving the highlights. Is that okay?
Yeah. I guess I have to read up more on them, don't I?
Yeah,
I'm not
yeah,
gonna. Yeah. From the idea of the idea of these classes that I see it's a sort of an overview.
yeah.
And then it's for me to sort of read into it further, and then if I've got any further questions, I can ask.
Yeah, yeah, that will be great, fine. Yeah. So,
Yeah.
uh, let me quickly go to the next, the unit. Sorry, the learning outcome 2. So, if you have a look at on the data integrity, so it talks about the data quality and quality control in the database management system, and data integrity explained, and data security. So quality is basically, the control in the database using certain constraints. Yeah. Like
Okay.
integrity, yeah, integrity constraints, they are basically, let me try to explain to you. this is about, the data integrity is to make sure that whatever the, for example, operations, limitations to the data, restrictions to the data. For example, restriction is that you cannot, put any non-numeric, field. Let's say name into the number. Can you put the name into the number field?
You shouldn't be able to, no, because of it should have like error checking, shouldn't it?
That's basically the constraints. Yeah.
Yeah.
That's the
Okay.
data integrity. It is the responsibility of the database to make sure every aspect of the data to follow the constraints. Make sense?
Yeah.
So that's about the data integrity, and further, the different types of integrity constraints are being discussed in the next, slide. Is that okay?
What in learning outcome 2?
Yeah, in learning outcome too.
Yeah, that's
Yeah.
fine. Yeah.
Okay. So after discussing these, types of protocols, a little touch to data integrity. Simple words: a quality maintained by certain constraints, and one more topic, which is the data security. And security is a very common that no unauthorized access to the data. Yeah. So you have to make sure that you understand what is the data security. It means no unauthorized access to the data. Yeah. So
Yeah.
let me come to the learning outcome 2. So what is the relationship in a database? We talked about a relationship in a database. If you could recall, we are here now. Learning outcome 2, database relationships, joins, keys, integrity, constants. Now here it is. Yeah. Integrity constants. It was talking about the integrity. Now integrity constants are applied using, let's say, referential integrity, domain integrity, entity integrity, foreign key integrity, then functional dependencies, database administration. So now we recall again the relationship in a database. So entities, for example, student, course, enrollment will have a relationship. So you can recall what relationship it can be. Yeah. So the relationship is normally, as we discussed earlier, one to many relationship, many to many relationship, and one to one relationship. Yeah.
Yeah.
These are, kind of highlights again. One course, is enrolled into the enrollment for many times. Make sense? Can you see?
Yeah. Okay.
That one and asterisk?
Yeah. I can see the ones.
So one course is enrolled into the enrollment, table for many times. Yeah. And again, many enrollments are done by one student.
Okay. Yeah.
And when it comes to the one course, like, many courses can be enrolled by many students, or many students can enroll many courses. That is basically the many to many relationship, and it is mandatory to have a third, connectivity entity, so that you can represent this. Do you remember, as I told you, that many to many relationship, it cannot be, let's say, course and student, steric and steric.
Okay. Yeah.
Yeah. So
Yeah.
one to many is clear, many to one to one is clear. However, many to many is only achieved by using the third, here is some definition about, the one to many, like one course enrolled into many times. Yeah. Then
Okay. Yeah.
Many to many is here is it is defined that it is only possible when you create a third entity, in between the course and student. Otherwise, literally, it is not possible, as I explained to you in early in yesterday as well and today. Yeah. And
Okay.
then
Yeah. Right.
one-to-one relationship is simply, that no cardinality, no more cardinality. And then,
Okay.
it's a primary key and the foreign key. Yeah. So are you clear about, do you have any idea of the primary key and the foreign key?
A primary key is a unique key, isn't it? In the table, there can only be one of them.
Yeah. Yeah, that's
A
fine.
foreign,
Yeah.
a foreign key. I don't know. I've never heard of that before.
Okay, no worries. So uh, let me ask you again. It's 2 minutes past 8. Should I continue sometime more, or we may discuss later on?
I'll tell you what. We'll shall we continue next time with this?
Yeah, that's fine. So
Yeah.
uh, let me just give you the answer to the primary key and the foreign key, and then we finish. And
Yeah.
in the
Okay.
next
Yeah.
lecture, I will finish this unit. Oh, sorry, the learning outcome 2 and 3 again. Yeah.
Yeah. Okay. Yeah.
Okay. The primary key is basically there's this true that it should be unique. Yeah. And
Yeah.
when you want to join two tables, yeah, and then you create a kind of the same key, you provide a same key in another table so that you should not duplicate. For example, customer ID should be, and its detail would be in the one table, and in order table you only use the customer ID. You don't need to repeat the details of the customer. Yeah. And
Okay. Yeah.
when you link the one table with another table, yeah, then it makes the connectivity called by the primary key and foreign key, you know uh, connectivity.
Okay.
Yeah, like it could be the case that order table could include all these last name, first name, street, and blah blah blah, but the database rule says that omit the duplication of the data, redundancy of the data, and use the primary key and foreign key which are common in two tables.
Okay. Yeah. That's
Yeah.
interesting.
Yeah,
Yeah.
that's
Okay.
interesting. And you retrieve the data using the SQL language. You say, I need this, record where the primary key is this, foreign key is this, and give me the data. Yeah?
Okay.
Yeah.
Yeah.
So that's interesting. We will discuss in the next, class.
Yeah. Okay.
Yeah.
All right.
So,
I'll speak to you next time.
yeah, sure. And hopefully what we will do, instead of 60 minutes, probably we might go for 70 minutes in the next class, so that this third learning outcome, including half of the second outcome, should have been completed, and we should be done with this. Yeah.
Yeah. Okay. All right. Speak to
Okay.
you next time.
All right. Thank you. Bye.
Thanks. Bye.